This is part 2 of the lecture for week 8 and will review basic descriptive statistics. Descriptive statistics describe, summarize, and represent data in a meaningful way such that patterns may emerge. After creating tests and collecting data, it is useful to use descriptive statistics to find trends or patterns in the data. First, measures of central tendency can be calculated. This would include the mean, median, and mode. Next, measures of variability may be computed, including the range, standard deviation, and variance. Measures of central tendency are the averages of data, while measures of variability are how data are dispersed. In the first part of this lecture, we will review these 6 measures. The first measure of central tendency is the mean. The mean, which is the most common type of average, is the sum of all values in a group divided by the number of values. For example, if we had 9 observed scores on a psychology quiz that were 8, 6, 6, 7, 9, 10, 9, 9, and 8, we would add up these scores and get a sum of 72. Since there are 9 scores, we would then divide the sum of 72 by 9. The end result is that the mean of the scores is 8. Another type of average is the median. The median is the midpoint in a set of scores. When looking for the median of scores, it is important to list the scores in order. So looking at our same 9 scores from the psychology quiz, we first want to list them in order from least to greater value. Then we would find the score that lies directly in the middle of all of the other scores. In this case, the median is 8. You may notice that there are 4 scores on the left of the median and 4 scores on the right. But what if there is an even number of scores and there is no middle? In this case, you would find the mean, or the most common type of average, of the 2 scores immediately adjacent to the midpoint. The last measure of central tendency is the mode. The mode is the value that occurs most frequently. Again, it would be helpful to have the scores listed in order from least to greatest value. From here, you would simply look for the score that is observed most frequently. In this case, the mode is 9, since 9 occurs 3 times, while the other observed scores only occur once or twice. Now we will look at measures of variability, which illustrate how scores are spread out. The most general measure of variability is the range. The range is a gross measure of variability. Looking at our example of 9 quiz scores, we would calculate the range by subtracting the score with the lowest value from the score with the highest value. In this case, we would subtract 6 from 10 and end up with a range of 4. This would give us an idea of how far away from each other the most extreme scores are spread. The most frequently used measure of variability is the standard deviation. The standard deviation represents the average amount of variability in a set of scores. In other words, it's the average from the mean. The larger the standard deviation, the larger the average distance each data point is from the mean of the distribution. This formula states that if you subtract the mean from each observed score respectively and square each result, then add all of the results together and divide this total sum by the sample size minus 1, it will equal the standard deviation squared. You will then need to find the square root of both sides of the equation in order to find the standard deviation. So in order to calculate the standard deviation for our 9 quiz scores, we would first need all 9 observed scores, in addition to the mean of the scores. Next, we would find the difference between each observed score and the mean. Then each difference would be squared. After this step, the results from all 9 calculations would be added together. For our 9 scores, the sum is 15. So now that we have our sum of 15, we need to divide it by the total number of scores minus 1. In this case, our sample size is 9, so we will calculate 9 minus 1. This gives us an equation that says the standard deviation squared is equal to 15 divided by 8. Once we divide 15 by 8 and get the quotient of 1 88/100ths, we just need to find the square root of both sides in order to find the standard deviation. we end up with a standard deviation of 1 37/100ths. This means that the average distance each observed score is from the mean of distribution is 1 37/100ths. The last measure of variability is variance. The variance is the standard deviation squared. So if we take our standard deviation from the previous slide and multiply it by itself, we will get the variance of 1 88/100ths. You may recall that we encountered this figure during the last step of computing the standard deviation. This occurs because if you look at the equation for standard deviation, the variance is the calculation on one side of the equation. Now that we have calculated the measures of central tendency and the measures of variability, what happens when we put them all together? In a normal distribution, we would get a visual representation shaped like a bell. This representation is called a bell-shaped or normal curve. In a normal curve, the mean and median are the same. In a case where these two measures are not the same, then the curve would be skewed to one side. Another characteristic of a bell-shaped curve is that the curve is perfectly symmetrical. Lastly, a normal curve has a tail that is asymptotic, which means that the tail gets ever closer to the x-axis but never touches it. Let's say we have a bell-shaped curve with a mean and median of 100 and a standard deviation of 10. Notice that the bell shape has been segmented evenly across the x-axis at each standard deviation. If we go up one standard deviation from the mean, there is a line at 110, and if we go down one standard deviation, there is a line at 90. Another trait of normal curves is that approximately 68% of all scores fall between -1 and +1 standard deviations. For this particular curve, it would mean that 68% of scores are between 90 and 110. The majority of the remaining 16% of scores on either side of the mean lies between -1 and -3 standard deviations, or +1 and +3 standard deviations respectively. As you can see, for a normally distributed bell-shaped curve, almost 100% of the scores will fit between -3 and +3 standard deviations from the mean. This rule allows us to compare different distributions to one another. Next, we will take a look at correlation coefficients. A correlation coefficient is a numerical index that reflects the relationship between two variables, such that we can observe what happens to one variable when the other changes. A correlation can range from -1 to +1, but the absolute value of the coefficient reflects the strength of the correlation. This means that a correlation of -0.8 is stronger than a correlation of +0.3, since the absolute value of -0.8 is +0.8. There are two types of relationships correlations can have, a direct or indirect relationship. Positive correlations have a direct relationship, signifying that the variables change in the same direction. An example of this would be the correlation that has been established between SAT scores and college GPA. The higher a student's SAT score is, the higher their college GPA is likely to be. Although these two are correlated, it may be interesting to note that some studies have found that college GPAs are more strongly correlated with time management skills than SAT scores. Negative correlations have an indirect relationship, meaning the variables change in opposite directions. So as one variable increases, the other decreases, and vice versa. For example, as the number of hours a person sleeps increases, the number of hours they are awake decreases. It is important to understand that although correlations describe the relationship between variables, they do not determine that one causes the other. In other words, correlation does not equal causation. This is a common misconception about correlations. Often people believe that one variable causes the other to change, but this simply is not true. For example, there is a direct correlation between the number of hours a child watches TV and the likelihood that they will bully other children, but this doesn't mean that TV watching causes bullying as often reported in the media. It is more likely that another variable, such as lack of parental supervision or lack of parental interaction, cause both types of behavior. Before we wrap up this lecture, let's practice interpreting some correlation coefficients of actual variables. First, thinking about the absolute values of correlation coefficients, we can see that there are general categories of correlations. Variables that have a correlation with an absolute value of 0.4 to 0.6 have a moderate relationship. Variables that have a correlation with an absolute value of 0.6 or higher have a strong to very strong relationship, and those with an absolute value of 0.2 or lower have a weak to no relationship. Here is a chart with correlations between 5 cognitive variables and age. Notice that while there are only numbers 1 through 5 going across the top of the table, these numbers signify the same variables as the numbers in the left column of the table. So 1 refers to working memory, 2 refers to executive function, and so on. Now take a look at the bottom row. Here we can find out what cognitive variables the variable age is correlated with and what type of relationship the variables have. Do you notice anything interesting? Are there any very strong relationships? What type of relationship is it? You may have noticed that age has a very strong relationship with a third variable, processing speed. This relationship is indirect or negative, which means that as age increases, processing speed decreases. Age also has moderate indirect relationships with working memory, executive function, and episodic memory, which is the type of memory we have when we're remembering past personal experiences. Lastly, there is a weak direct relationship between age and vocabulary, meaning that as age increases, there is also a weak relationship with the increase in vocabulary. Finally, as you are studying for the quiz this week, practice answering these questions. What are the measures of central tendency? How are they calculated? What are the measures of variability? How are they calculated? What are the main characteristics of a bell-shaped curve? Why are correlations useful?